When we want to apply stack, we can use array. That's we call as array-based stack. This is a simple way to implement the stack ADT. So a simple way of implementing the stack ADT use an array. So we can add the elements from the left to the right. So at the first element, it is index 0, the second element in index 1, the next element in index 2. So we can say that this is the top. This is the top. A variable keeps track of the index of the top element. So we will always check what is the top. So if there is a new element, so this is the next top. If there is a new element, then this is the next top. If there is a new element, then this is the next top, and so on. So the array, you know that the array storing the stack elements may become full. Full means space always have limitation. Maybe we have the element as much as 10, or the capacity is only 10, then it means we need to grow the array. Okay, so the previous section we learn about the grow array. A push operation will then need to grow the array and copy all the elements over. So whenever you do with the array, actually the computer will do for you to add the new element with the growable array. So the performance of this array-based stack, let n be the number of elements in the stack. So let's say if I have the stack like this one, element 1, element 2, element 3, element 4, and so on. So let's say this is n elements. So we use the space as on. We use the space because if we have n element, then it means the big O is on. Its operation runs in O1. We use the amortize time. In the previous section, we learn about the amortize. So we learn the amortize. It means the amortize is the average of the operation for the push. So let's say if I have 1, 2, 3, 4. So the Tn, it means we will have n operation. We have n operation and we have n data. Then it means we have 1. So the each operation will run one O1. This is both for the push and also the pop. I will explain this code on next week, Wednesday, because I think I need to complete the array and the queue by today and on Monday. So the example of stack, something like this one. Do you know parenthesis? One loop. Okay. Whenever you do the parenthesis, like this one, this is the opening. You need to have the closing. If you have the curly braces, the opening, you need to have the closing. Or if you have the square bracket, you need to have the closing. Because this is the parenthesis matching, it means each of these maths must be paired with a matching. So if I have this bracket, then it should be matched with the closing of this one. If I have this one, I should have the matching with this one. If I have this one, I should have a match with, oh, sorry, I have this one. Then I should have the, like this one. Okay. Then if I give an input like this. So if I have an input like this, then this is correct. Because opening, closing, opening, opening, closing, closing, opening, closing, opening, closing, opening, closing, opening, closing. Okay, this is maths. This is also correct. Opening, and then we have closing, opening, closing, opening. Oh, maybe this is not correct. Yeah, opening, closing. This one opening, closing, opening, closing, opening, closing, opening, closing. Maybe this should be also one more. Okay. Let's do now. Let's check later about this one. Incorrect. What is the meaning by this incorrect? Okay, we have the closing, but we now have the opening. This is incorrect because the location, this is opening, 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 and then this is closing. But the closing here is for this one. But this one should come first. So the order is different. So this is incorrect. This is also incorrect because only one. No closing. So the algorithm should determine whether it is correct or not correct. Or maybe let's see just very simple. This one because of the array stack. Let's just understand this one, the constructor. The constructor means I want to construct from empty list. So the data is empty, and then I can check the length, means how many data do I have in the data is empty. So I want to know that the length of the data equals to 0. If the length of the data is 0, then empty. I can push. Okay, so push means we want to append. And the top. So I want to know whether the top is available or not. At the first time, I need to check if it is empty, then raise the error. The raise means we want to give the error message without stopping the Python code. So this stack is empty. If it is not, then we will do the checking the data -1. You still remember? -1. If we have an array 5, 2, 3, 4, 6. So this is the data. Data -1, it means it will be equal to the last element. This is 6. Okay. So we want to know the top. The top is the last element from the array or the last element from the list. Top means we want to remove. We want to remove the element. In this case, we want to check whether it is empty or not. So if it is not, then we just do pop. So in array or in the list in Python, we can use pop just to remove the last element. can just use pop to remove the last element. And then pop, so we remove the last element. And then we remove the last element. So this is matching. Yeah, it can be one of the example on the stack. So this is the algorithm. So the input is an array X of n tokens. So it means the token like this one. This is what we call as token. Each of which is either a grouping symbol or variable or an arithmetic operators or a number. So you can have anything. For example, do not want to do the parenthesis, you want to make some kind of variable, or you want to do the arithmetic operation, we can do with this one. The output is true or false. True if and only if all the grouping symbols in X match. So the first will be S with the empty stack. So S will be the empty stack. So let's say this is empty. And then we will do the loop. So if X is an opening group symbol, Xi. So I means it starts from the index 0. Then push. So we will put, let's say, yeah, let's say we have the symbol like this and this one. So if the first element is an opening grouping symbol, push, and we push like this one. Else, if X is a closing grouping symbol, then check whether S is empty or not. If it is not, if it is empty, then false. If it is not empty, then pop. If you do the pop and the pop does not match with the xi, then false. So when we have the first, okay, we have this one. And then we go to I equals to 1. Which is an opening grouping symbol. It means when it is the index 0, this is index 1. What is the opening grouping symbol? This is closing. Then we go to the X. X is closing grouping symbol? Yes. Okay. And then check. S is empty. This is S. S is empty? No. Because no, then check this one. If S stop, so we want to remove this one. When we remove this one, check if this is a matching with the type of xi. So this is matching with this one. Then true. If it does not match, then false. We already did a pop, so it means this will be empty. If S is empty, then true. Otherwise, false. Some symbols were never mixed. So this is the algorithm for the parenthesis matching. We can specify like this one, lefty and righty. Lefty means this one at first, this is second, this is the third. And righty means this is the first, this is second, and this is the third. So we can do the loop like this one. We need to check whether C is in the expression. If C is in the lefty, the lefty is this one, then if it is correct, push. If it is not, then else if C is in the righty, so it is the closing. And I check if it is empty, false. Or the righty index C not equal to lefty index S, false. and is false. S is empty, then this will be the return value. So using this algorithm, you can measure whether it is ON or ON power of 2 or O log n. Okay, so try to figure out. The second possible application is HTML tag matching. If you learn about the web programming, in the web programming, you will learn about the HTML. And for the HTML, for fully correct HTML, its name should pair with a matching name. So let's say this one, body. So I have body. It is to indicate that this is a text in the web. And at the end should have the closing. The closing means we need to close with the name body, but we need to include access. We can have center. So this is the name in the HTML. And in some point, you need to have the slash center. So because this is the starting tag, and this is the ending tag. This is how the HTML works on the web. In order to check whether the tag here already meets, this one already meets, this one already meets, this one already meets. So we need to make the algorithm. So this is the algorithm. The tag matching algorithm in Python. We need to have one input, which is the raw. Raw means the HTML file. And then we will do the array stack. You still remember the array stack? The array stack that we learned before is this one. This is the class. So we call this the ADT. Because this is the ADT. When we have this ADT, the array stack, so we can apply in any kind of application. Okay, we can apply in any application. For example, in this case, I will use the array stack. So I use the base or the abstract data type, or I can say this is the ADT that I use from the array stack. And then I will apply it to the tag matching algorithm. So this is the algorithm that you want to apply, and we use the array stack. And first, we want to check whether the raw include the triangle bracket. If the raw find this one, so let's make it as J. If J not equals to -1, so it means if you find, whenever you do the searching, in the searching algorithm, I think if you learn in the computer programming, the searching algorithm can give you the index. It can return the index from 0 until n-1. If the return equals to -1, it means we cannot find the value. So we cannot find the value if the value is minus. So in this case, we want to find the triangle bracket. If the value is not minus one, so it means if the value is 0, 1, 2, and so on, then do this one. If the value is already minus one, stop. So again, we will check. The norm find this one. If the norm find this one, so we will check. After we find it, we will do the addition to the j plus 1. Again, we will check k equals to minus 1. So it means if we cannot find it, so if we find, now if k equals to minus 1, it means we cannot find it, then it returns false. So it means the tag does not match. And go to the next. So we will check the tag. So the tag will be from the j plus 1 until k. So this is from the beginning until ending. And then we need to check if the tag starts with 6. Then if it starts with slash, then push tag. If it is not with this one, then we do this one. If it is with the slash, then check whether it is empty. If it is empty for the S, then return false. And then we can check whether the tag it is top or not from the index 1 until the end. So if the is not equal to the pop, so it means if it is not equal to the tag, then return false. So J will be again checking the triangle bracket and it will start from k plus 1. So this is a loop until we finish all the HTML file. So using this algorithm, you can also measure what is the pico. What is the pico? So you know the operations, then you can calculate the pico. The other kind of application using the stack we can use for the arithmetic expression. In the arithmetic expression, you know, in Python, we have the operator precedence. You remember when you learn the computer programming, you will know that multiply has the precedence over plus or minus. So, for example, 2 plus 3 multiplied by 5. What is the result? 30 or 17? Plus 3 multiplied by 5. Is it 30 or 17? It is 7. Because 3 multiplied by 5 will be first. This will be first, 15, and then plus 2. So the result is 17. Oh, sorry, this one actually 2 plus 3. Okay, 2 plus 3 is 5. 2 plus 3 is 5, multiplied by 5, it should be 25. Okay, not 30. Why not 25? Because multiply has a higher order than plus. So that's we call as the precedence. In order to make it, if you want to make this result as 25, then it means you need to have the bracket. Because this is the associativity. So 2 plus 3 multiplied by 5. It means we will do this addition 2 plus 3, 5, and then multiply by 5. Then this will be 25. Okay. Now, how can we do this one with the step? So the associativity means operators of the same precedence group evaluated from the left to the right. So whenever we do this calculation, we will go always from the left to the right. So the idea is to push each operator on the stack, but first stop and perform higher and equal precedence operations. So if the multiply comes first, then do the multiply. So there are two steps. So the OSTK. So this is the operators. And then the file STK. This is the value. So for example, 4 plus 5. Then 4 is the value, plus is the operators, and 5 is the value. You can use dollar as a special end of input, often with the lowest precedence. So the lowest precedence, let's say if we have only plus, minus, and multiply, then the lowest precedence will be this one, and this will be higher. Now we can do the algorithm, do the operation. X, let's make the value STK pop, and then Y is the value STK pop. And then the operation will be pop from the operation STK. So it means we have two stacks. It is for the value, and this is for the operations. If you have 4 plus 5, so something like this. So this will be repeated until the size is higher than 1 and the precedence of the reference op is less than or equal to the precedence of the operation at the top. And then do the operation. So we will do again the operation. So the algorithm is to evaluate the expression. The input is a stream of tokens representing an arithmetic expression with numbers, and the output will be the value of the expression. So this is the algorithm. While there's another token, so check. If it is a number, then push on the value. So value is number. If not, then repeat the operation. So repeat the operation. And the operator push. Push the operator. And then repeat the op until we have the end. And if it is still in the loop, okay, do the loop until you check. So maybe it is easier to look at the simulation. Now I have the 14 less than equal to 4 minus 3 multiplied by 2 plus 7. So the operator less than equal has lower precedence than plus or minus. That means the multiplication will be the highest and then plus, minus, and then this one. So at the first, yeah, we will do care the this one. So for we have 14, we put in the stack, we put 4 in the stack, and then we put this operator in this place. We put the operator in this case. And then we have the operator multiply, we have the value 3. Okay, now we find that multiplication is the highest operators, and then after we check the number values 2, so we will not add this one at this moment before we put into the stack. So we will do the operation. 2 multiplied by 3 will be 6, and then after that we will push the plus into this. So we will do the operation for the plus after we put the 4 minus 6, which is minus 2, and then we put here, and then at the end we will plus with the 7. And yeah, we will have the last one, whether it is less than the value, which is 5 or not. And the result will be false. So we can use set to indicate this kind of mathematical operation. Okay, I will stop here.